Hello, and welcome back to Let's Play Satisfactory. In the last episode, we finished the first of our 4 final products, heavy industrial frames. And I've decided it makes the most sense now to move on to the second product of supercomputers. And we're going to start that off with high-speed connectors. Now, for high-speed connectors, we're going to need 12 manufacturers producing high-speed connectors to meet our demands. Let's make sure. I think we'll probably have to make a supply run here. 12. Yep, short on a few things. Heavy frames, motors, cables, and computers. So while we're down there, let's just get make sure we have enough for everything that we're doing this episode. We need, 12 manufacturers for high-speed connectors, another 8 for supercomputers. So let's just add that to the list. And then we need, 12 assemblers for computers. And that should be about it. Yeah, the fourth ingredient is plastic, which we already have set up below. So 12 assemblers for computers. And that's what we'll need. Do we have enough space for this? Our inventory? Well, we can get rid of some stuff here. We don't need those. We really don't need this rubber. I don't know why we have... Oh, I do know why. We have so many frames on us. So it's looking like this series will wrap up in about 41 episodes. I believe this is the 39th episode. I was hoping to get down on 40, but I think we're going to need 41. Let's fly over the toxic gas. Okay. We don't need nearly so many modular frames. We need 100 heavy modular frames. Okay. 100 motors. Let's get a few more. We'll need those for motors and turbo motors when we get to them. Lots of cable. And then 100 computers, which are inside. This one, I believe. Alright, we'll grab another stack for the future. Whew. Okay, close one. It's looking good, right? Pretty clean. Nice scale. Let's sort this inventory. Okay. So, high-speed connectors, that's what they're called, I believe. And 12 manufacturers. Start them over here. Let's give us plenty of room. Bounding box inside the foundation. Let's take a look at the recipe. alternate high-speed connector, quick wire, silica, and rubber. We may need 2 lines of quick wire here, because these require 82.5 per minute. That's something to consider. I said, what, 16 of these? 12. Okay. So this is going to take up a fair amount of space. 2, 3, 4, 5, 6. Okay. Let's see. We're going to output these to the north. Let's get our merger. Leave 1 space. Do we want to output these to the north? Maybe a better idea. Let's output them to the south. Let's push that up. So this is our high-speed connectors. They'll be used in supercomputers, which is the final project we hope to finish today. It's got a few pieces to it, but one of those pieces, the AI limiters, we've already got in production. Plastic, that's already done. So we just need, I think we just need these high-speed connectors and then computers. And the alternate recipe we're using for computers is actually done in an assembler, not a manufacturer, because we're using the crystal computer alternate recipe, which is a lot easier than the standard recipe. Crystal computers just require the circuit boards and crystal oscillators, which we've already made. So that'll be really fast to set up. I chose to move on to supercomputers next because supercomputers are actually used in the alternate recipe for radio control units. And that we're going to use that alternate recipe for radio control units in our alternate recipe for turbo motors. So it made sense to get supercomputers done before turbo motors. Turbo motors are definitely the most involved of any product. You need quite a lot of subcombines for turbo motors. It's just facing the wrong way. Yeah. I mean, having supercomputers as a subcombine for not even the final product, that's kind of nuts. Because supercomputers themselves require a lot of subcombines and resources. I think I used splitters there instead of mergers. That was my bad. Okay. Let's switch back to the jetpack. Let's set up these recipes. Okay. Now, the products we need for this, silica, rubber, quick wire, is that right? Let's do some math. 82.5 per minute times 12 machines, that's 990. That means more than one belt of quick wire. I think everything else should be good. So we'll need 2 belts of quick wire and 1 for the other products. Now, which belts? We're using the bottom 2 belts of quick wire already, is that correct? For circuits? Or not circuits, but AI limiters. So we'll use the top 2 belts now for high-speed connectors. What else we're using quick wire for? Is there anything else? Stators later. But stators should need a ton. But it looks like what we may end up doing is merging a few of these quick wire lanes to feed the stators at the end, and that's fine. That's not a problem. Because I'm not sure that, I'm pretty sure that all of these quick wire from these bottom 2 lanes are not being used, and we won't use all of them from the top 2 lanes either. So those lanes will still be partially full. Okay, let's give ourselves plenty of room here since we're working with 4 slots. We'll say right here. 1, 2, 3, 4, even though we're only working with 3 components. 4, 5, 6, okay, it needs to go between these 2. Two, 3, 4, 5, between these 2. 1, 2, 3, 4. Okay, we'll make it to the end here. So we'll say right here. We'll have 4 lanes right there. 4 lanes here. And then we'll go up the length of 1 foundation and condense that down to 3 lanes. Okay, 1, 2, 3, 4, 5. Is it on the vent? Yep. One, 2, 3, 4. Yeah, that'll be enough. Only 3 high now, because we'll only have 3 belts at this point. Let's go 1 over. One, 2, 3, 4, right here, between the machines. You want to be careful when you're placing conveyor poles between the machines because you want to give yourself enough room so that the splitters are not overlapping with the conveyor poles. Alright, and then all the way to the end here. Now we're merging to the south. Let's set up our storage container. Okay. Okay, now let's leave that for now. Let's think about until we know exactly which products are going to be in which lanes. Really burn through belts when you do even these limited 4-lane stacks. Alright, so we'll have everything coming in here. Three, four. Let's leave it here. Give ourselves enough room for the slope. So top 2 lanes of Caterium. What is it? Silica and rubber? Is that right? Silica, rubber. Okay. So rubber's on the bottom. Where's the rubber? I believe it's here. Let's double check that. Really wish you could color code these belts. There are 2 lanes of rubber. We're going to use the top one. So up here, now let's try to align that with our conveyor poles as much as possible. Okay. This bottom. Next is the... I don't actually need another pole here. Top 2 lanes of quick wire. Okay. We need to offset them a little bit from each other so that we're sure that they stack to the belt and not to each other. And then silica. Man, that's high. Yeah, I thought those would be too high. Can we just add another conveyor pole? Will that work? What about one more? I'd really like to avoid using lifts. Possible. How many is it going to take? This is so tall already. Okay, that works. Okay. Okay. We've made it work. We can remove that top one. And now, these should all... Yeah. Alright. You know what, that works for me. We can actually raise this to this level. There's no need to not do that. So it will look slightly less crazy there. So the bottom is rubber. Quick wire, and silica. Cool. Now when we come over here, this bottom belt of quick wire will be used for the western side of manufacturers. So we'll wrap all these around, except for that bottom belt there. And then we'll just condense these. Perfect. Let's add our splitters. Now we're only using 3 lanes per manufacturer, so we'll just skip the last input, I guess. Let's make sure this is far enough back. I probably should have done a test. Okay, it works. Excellent. So that's silica. Now we're using the bottom lane of quick wire, and then rubber. Next machine. Silica, quick wire, rubber, silica, quick wire, rubber. This is a large setup. I was surprised that we needed such a high number of manufacturers for the high-speed connectors. I'm not upset about it. This setup will give us just a little bit of excess for high-speed connectors, which is good because they're the basis for the Mark III electrical poles as well. So that little extra will allow us to accumulate a stockpile to have for future Mark III poles. Now this side we've only got 3 belts, so there's no skipping. And the last 2 manufacturers. Okay. How are we on belts? We're gonna need more. Let's see how far we get. We'll finish one side. It's pretty good. Okay, 1 belt left. Let's go grab some more. On our way back, let's just, is this power pole full? Oh, perfect. So we can just, see, how did we do this last time? We've got 12 machines, that's too much for 1 power pole. Put 1 here. We'll connect that to this one. And this will power all the machines on the western side of the output belt. Oh no, the wire's too long, I forgot. Okay. 1, 2, 3. We'll set it up in the middle here. Alright, let's center this. Power pole mark 3. Right there. Let's put another one on the other side. Okay. Whoa. These two will connect. Now, is this one gonna reach? Too long. Okay, so we'll put another pole right here. A little connection pole. That connects to this pole. And then this. Well, I connected these two machines together. That's not going to help either of them. Oh, come on, really? Trying to hit the cable, it's not gonna happen. It's fine. Okay. Let's be very precise here. Okay. Western side is done. Let's run back and set up that belt before we forget about it. And the recipe. What are we making here? Alternate high-speed connectors. There we go. Now we'll do the east side. Okay, power's hooked up. Let's run and grab our belts. Hardware and everything else. Okay, we'll add another stack of concrete and a few more iron plates. Good enough. There's the save. Whoa! The hit from the save really sent me flying there. Did we make it all the way to the end, or were we a little bit short? No, we finished it. Good. Okay, let's connect these belts. And we should be in business. High-speed connectors. There they go. Let's check all of the LEDs. This one. Is it because we're waiting for products? Green? All green. Okay, good. Let's check our power, see where we're at. Okay. 5.7 gigawatts. That's a fraction of our total power production, so we're good. Next on the list, computers. Now we're using an alternate recipe for computers. We need 12 assemblers. The standard recipe for computers, I think, is 4 ingredients and made in a manufacturer. Let's check it out. Computers, yeah, 4 ingredients. Circuit boards, cable, plastic, and screws. What a nightmare. Screws, no one wants to deal with that. Instead, we're using a recipe that has only 2 ingredients, so it's made in an assembler. Crystal oscillators and circuit boards. We need 12 of these, so we'll do 6 on each side. These we will merge to the north. Well, let me think about that. No, we'll also continue to merge to the south. That makes the most sense. 1 space, outputting to the south. Six more assemblers. Aligned, and 1 space out. Alright, let's do recipes first. I'm getting very excited for the release of Update 3, even though we're probably still a month out. They also said that they would, they're working on permanent servers for playing this game over multiplayer, and that should be exciting too. I'm kind of hoping they raise the limit on the number of people. Right now you're limited to 4 people in a game, which is nice. I mean, 4 people, it's like it's just amazing at how much faster all this goes with 4 people. It's like almost 4 times as fast. That's some crazy math. But it feels so much faster than that because you can just, the way you can divide the labor for, you can have, you know, like one person focused on exploring, one person focused on, you know, excavating new mines. I'm just gonna test this link. Actually, we should probably redo this and have it aligned with the conveyor poles to the south of us. Looks like they're on the vent here, so we'll use the vent as well. Just for the purpose of making it look as good as possible. I think that the slope of the belt would have been fine. On the vent. Perfect. 1, 2, 3, 4, 5. Now these are on the edge. Two, 3, 4, 5. We can do it here. I think the belts are long enough to reach that far. Yeah. And then we'll take it all the way to the end here, to this edge. Now here's one unfortunate thing. We've got our computer set up behind our crystal oscillator setup. Not ideal, but I didn't want to push the computer setup out to the east because these computers will be used in supercomputers, which will probably place in front of the crystal oscillators, and then that supercomputer will also be used in radio control units. So I was just thinking about the best way to allot the space for this floor of our factory. And I am happy to say that I think that everything will fit nicely onto this second level, and we won't need to construct the third level for any of the products that are currently available. Alright. So for this we need circuit boards and crystal oscillators. You know what we should have done, and that actually makes much more sense. Let's remove all these belts, and we're going to have them flow in the other direction. We'll have them flowing from south to north. Oh, tell me I didn't. Okay. I almost deconstructed a splitter there from our high-speed connection setup. It's not ideal. I don't understand why it says I'm deconstructing. I must have highlighted something I didn't intend to. The deconstruction materials should only be the alkylate aluminum sheets. If anything else is listed there, I've made a mistake. Okay. Now we leave all the conveyor poles, and we're just going to... I don't know what this is for. Okay. We're just going to flip the direction. North to south. Which direction are we outputting here? Are we outputting to the south? Yeah, we are. Okay. Okay, well that design change cost us 2 minutes, but I think it's going to be worth it. Yeah. Do need to pick up the pace if we hope to finish supercomputers this episode. It's gonna be tight. Okay. So we have crystal oscillators. We really should have had those outputting, the crystal oscillators outputting to the north, but it's fine. You know, what's done is done. Now here's what we're going to do. These are AI limiters. We need to come back here. Oh man. Oh well. Maybe we shouldn't have flipped those belts. It's fine. What I'm going to do... It's not a great way to do this. I guess we're going to have to go out to the side here. Okay. No clipping, that's good. But here's the hard one. Oh, that's wrong. Oh, that's a lot of clipping. That's better. There we go. Now we're going to use that top belt of circuit boards for our computers. Let's find our output for crystal oscillators. It's all the way up there. Yeah. So we'll just bring that all the way up. There's the save. Not doing great on time. Okay, I'm going to bring that forward. 1, 2, 3, 4, 5, 6. It's on the vent. And now I think what we're going to do is we're going to add another set of poles here. It's all in the vent. Okay, and all the way back here, grab our circuit boards. The slope caused that to be too long. The vertical distance counts. Okay. It's going to wrap around. And we'll just have this go on top, I guess. It's probably going to be too far. It's definitely too far. It's fine. Okay. Wrap it all the way around back here. Want to go one more? Yeah. Let's go a few more to avoid clipping. Is that going to work? Would this work? Okay. Let's go grab our belts. These giant manufacturers are just completely wrapped with conveyor belts. Looks kind of cool. And the belts are going in opposing directions. But it's all still fairly neat. They're just vertical belts, completely aligned. No spaghetti. And then this is why we changed the direction of these conveyor belts, because we can just bring these two belts right here. We'll condense them down a level. All right. Now the easy part. Let's do the middle while we're here. Which direction are we outputting? To the south again? Yeah, we still do the south. We did not set up an output here. Now this is an issue, because we've got these belts right here. But, you know, I think it's going to be fine. This is where we would usually put it. Yeah, that'll work. Computers. Okay, a few more splitters. Threw me for a second, seeing which direction those arrows were facing. Too close. No, it's gonna work. Alright, connect the belts. And 12 more belts. Now we just need some power. 12 machines is it's too many connections for one Mark III power pole. But, you know, it seems a little crazy to me. I think they should scale up the amount of connections that one Mark III can handle, because the requirements to build a Mark III is so much greater. You know, for the Mark IIs, you basically just replace wire with quick wire, but the Mark IIIs require the high-speed connections, you know, which is quite a few materials just for that one piece. And then you also need steel pipes in addition to that, so it's a lot. It's a big jump. Let's see. Let's put this over here. Is this too far? Yeah, just barely too long. We'll see which one of these works. Good. Alright, then a power pole over here. Connected to the previous power pole, and then to the 6 on the east side. What do you mean floor is too slim? There we go. The last one, we all good? They're all green. And we're making computers. Crystal computers. At a pretty good rate, too. It's nice. Look at those circuit boards and crystal oscillators rush in. Alright. I'd hope to get to supercomputers, but we're at an hour right now. This is a great place to call it. We'll pick up with supercomputers in the next video. Please like and subscribe. Please. Please. And I'll see everyone in the next video. Thanks for watching.